Hello,
Hello, hello.
am I audible now?
Am I audible now? Am I audible now? Am I audible now?
Hello, hello, am I audible? Can anybody please confirm if I am audible or not?
Going, sir.
Yeah, I don't know why this is problem is coming. Is the echo is very high, right? Can I continue like this or is there any problem? Is any hearing you?
To start to speak, it starts echoing.
Yeah, I am also getting that echo sound. Can you hear me now?
Yes, sir.
Okay. The sound is not echoing now, right?
No, sir.
Okay. Yeah. Okay. Good evening, everyone. My name is Ranjan Bora, and sorry for the technical error from my side. And my name is Ranjan Bora, and I am the one of the TA in this course, Biomechanics of Joints and Orthopaedic Implants. This course is instructed by Professor Sanjay Gupta from IIT Kharagpur. And today is the week 2 of tutorials. Week 1 I had on the last Saturday, and that video is available on my YouTube site. I hope that all of you has gone through that video. In that video, we discussed about the basics of biomechanics, like forces, moments, and we did some numerical problems in related to biomechanics. And in today's video, we'll first solve the week 1 assignment. Then we'll again do some numerical problems. Difficulty level is higher in today's video. The difficulty level of the problems which I will take today, and I will also cover some concepts from week 2 which will be useful for you to solve the week 2 assignments. I think we are already late, so we should start. So week 2 videos have been uploaded on NPTEL. So have you all gone through that video? Gone through all the lectures of the week 2? Anyone? No one has gone through the videos? You can use the chat box to reply, or if it is inconvenient for you to unmute and speak, or you can speak also. Anything is fine.
Last week I failed to attend, sir. Within the first class.
Yeah. So you have time. You can go through all the videos of week 2. Week 2 assignments, I think, has already been floated, and the deadline for submission is next Wednesday. So before Wednesday, you go through all the videos and then do the week 2 assignment and then submit. So in today's first, I will solve the week 1 assignment. This first question was, which of the following region in a femur bone is composed of cancellous bone with a thin layer of cortex? So what is the answer? Can anybody respond?
Diaphysis.
Uh, is it diaphysis? This is a femur bone.
Epiphysis.
No. See, which part is it is talking about? In the femur bone, uh, this part, we have this part, and then we have this part. So what is this part? This part is epiphysis, and this part is Anyone know? This part is metaphysis. And this part is diaphysis. So in the question it is asking femur bone is composed of cancellous bone with a thin layer of cortex. This diaphysis part, you are saying this part is composed of full cortical bone, hard cortical bone. This part composed of hard cortical bone. And this epiphysis part composed of cancellous bone. And this metaphysis is composed of cancellous bone with a thin layer of cortex. The answer is A. And next question, which of the following is not a function of muscle?
Blood cell formation.
Yes. And blood cell formation is function of which part of our musculoskeletal system? Sorry?
Bone and bone.
Yeah. It is a function of bone. And the functions of muscles are given here, like it is responsible for motion, maintenance of posture, and heat production. And which of the following attaches one bone to another bone?
Ligament.
Yes, ligament. What does tendon do? What the it attaches to?
Muscle to bone.
Yes, muscle to bone. Which is the strongest bone of the musculoskeletal system?
Femur.
Yes. Which of the following works as an actuator of the limb?
Muscle to tendon.
Yes. Next, which of the following is not a joint classification?
Connective.
Yes. We have seen in the last lecture. If you gone to go to the video, you will find these classifications are based on structure of a joint. And which of the following joint is an immovable type of fibrous joint that can be found on the skull?
Suture.
Yes. So this is the figure. You can see here we find this joint suture. Which of the following joints contain fluid-filled cavities?
Amphiarthrosis.
No.
Diaphysis.
Diarthrosis. This C. These are also known as synovial joints. Yeah. We have seen like amphiarthrosis means these are slightly movable joints. And these are synerthosis. These are removable type of joints. Like we have seen, yeah, these immovable type of joints, these are known as synerthosis. And amphiarthrosis means slightly movable joints.
Sir, there is any reason behind naming this as syntherosis, amphitherosis, or diatherosis?
That reason means I I don't know that about that, but there must be some reason related to anatomy. Means I don't know proper meaning of this in anatomical terms. They must mean some meaning in anatomy, so I don't know that.
Okay, sir. So syntherosis is slightly more
Immovable,
not
immovable.
movable,
Yeah, yeah.
immovable, and amphitherosis is
Slightly
slightly
movable.
movable, and diatherosis is movable.
Yes, yes, yes.
Okay.
So this is a, you can see this is a hip joint, and this joint here there is diatherosis. Means the joint cavities here uh, filled with some liquid which facilitates the joint movement. If there are no liquids present here, then this bone and this bone surface and this bone surface, they they get wear out. This surface of bone and this surface of bone, there would be more friction if there is no lubrication here. So these liquids acts as an lubrication, and they reduces the friction between the bone surfaces. And what type of joint is the temporomandibular joint?
Colon separate joint.
No, no, no.
Saddle joint.
Mhm. See, we have temporomandibular joint here in our mouth, sorry, in our skull, and it connects the mandible with the skull. This is mandible, and this is upper part of the skull, or we can call it skull. So this joint connects the mandible with skull, and what are the motions of this joint? What are the movements facilitated by this joint? We can like with using this joint, we can open our mouth, like we can open our mouth, then close. Then what we can do? We can do some gliding also towards front and back, little bit movement. So
Saddle joint, right, sir?
no, it is not saddle joint. It is a hinge joint. B.
Okay. But hinge is okay.
Yeah, hinge movement also like that only. Uh, Means if it is a hinge joint, then it can move like this. This is a hinge joint.
Okay, sir.
Saddle joint you are talking about, that is something different. Like it
Yeah,
has a, yeah,
it's kind of
yeah, it has a saddle shape,
sliding.
saddle
Hinge
separate. Yeah,
joint is opening.
yes, yes,
Yeah.
like this.
Yes, sir.
In our hands, we can see this joint, saddle joint here. This, I think this joint, here is saddle joint. So which of the following joints allows supination and pronation? Sorry.
Hand,
Yeah. So which joint in the options?
elbow joint.
Yes, yes. So supination means this motion is supination. When the palm is facing anteriorly, and when we we do the movement and face the palm posteriorly, and this is known as pronation. Next, hip joint is an example of
ball and socket.
yes. So this is the ball and socket joint, you can see. And if we consider this as femur, then you can see this socket part, it is here. Sorry, this is the socket part, upper part is socket part, and this is the ball. So the head of the femur acts as a ball, and the cavity of the pelvis, this acts as a socket. So this femur, it can have these movements similar to ball and socket. The articulation of the femur is similar to ball and socket. That's why it is an example of ball and socket joint. Next, condylate joint belongs to the class of
Synthesis.
no, we have seen like synarthrosis means immovable joints, right?
Amphithesis.
No, amphiarthrosis also slightly movable joints.
So,
But
sorry, diarthrosis is fully
yes,
movable joint. Right?
yes. You can see in our fingers we have this joint, and we can.
But okay, so this is not okay. Okay.
Yeah, we can freely more rotate our finger like this, or we can do these motions. Because of this joint, we can perform these motions. And which is the largest synovial joint in the human body?
I hope hip. Sorry, hip. Hip right. Hip.
No.
Hip or knee. I am confusing.
Yeah, knee joint.
Knee joint.
Yes. And ball and socket joint belongs to the class of
Diarthrosis.
yes. At Gomphosis joint, bone ends are united by
Side is not there.
okay, sorry. Yeah. At Gomphosis joint, bone ends are united by
Cartilage.
no.
Well, to regular tissue transfer. Collagen fiber.
yes. If
So
the
cartilage are
yeah, we have another type of joint for cartilage. We have cartilaginous joint.
so suture is composes, right?
Yes. Suture. I think I have to check that. Suture is yeah. If it is Gomphosis, then the ends are united by collagenic fiber.
Okay. Okay.
And what is the class of joint that connects the neighboring vertebrae in lumbar spine? Lumbar spine. You can refer to this figure to answer this question.
Fibrous or cartilaginous? cartilaginous, right?
Yes, yes. Because you can see like these are the cartilage. This blue color.
Okay, blue color and blue.
Yeah, the blue color part is cartilage, so it is a cartilaginous joint. And which of the following factors influence the joint stability?
Shape of the articular surface.
Yeah, but shape of the articular surface influence the joint stability. What about the ligaments, tendon?
Ligaments is a, but if the shape is not proper, then also joint stability influences, right?
Yes, yes. But the joint means with the joint there are ligaments and tendon also. Like with the joints there are, you are correct, the articular surface matters in the joint stability. But connecting to the joint there are ligaments. If the ligaments are not proper, if the ligaments are not proper, then the joint stability also there will be problem. So ligaments also influence, then tendon also influence, because tendon is connected with the muscles.
Then all of this will come, right?
Yeah, all of this. Okay, the rotator cuff is a group of,
Ligament.
no,
Muscle of the shoulder.
yes, muscles.
Okay, muscles.
Mm. And which is an autoimmune type of disorder?
Osteoarthritis.
No. If you have gone through the week 1 lectures properly, then you should answer all the questions. All these questions are from week 1 slides. There is no question from out of the syllabus. Everything is on slide. Every question is on slide.
Rheumatoid arthritis or
Yes, rheumatoid.
osteo.
B option.
Rheumatoid arthritis.
Option B is correct.
B.
Yes. And how many vertebrae does a functional spinal unit consist of?
I was the two.
Yeah, it is 2. This is a functional spinal unit. So yeah, this is, so it has 2 vertebrae. And the main function of the lumbar spine is,
Hold the rib cage. Hold the rib cage.
no,
Here the waist and the upper body of the body.
yeah,
But then lower back means lumbar.
yeah, you are, I think this function is provided by another part of the spine.
Thoracic cage. Thoracic.
Yeah, thoracic case, yes.
Yeah, thoracic region.
Yes.
Yeah. Lumbar spine is lower back. Yeah, bears the weight.
Yeah, lumbar spine on the below of the spine. Okay, so now I will cover some concept from week 2. Like in the week 2, there are concept about degrees of freedom. So anyone knows what is degrees of freedom?
In statistics, I know.
Yeah, you can. This is related to statistics only.
So in statistics, while we do t-test,
Hmm.
the total from total sample we minus one.
Sorry,
Then
that is not related.
Degrees of freedom is the possibilities, sir.
Yeah,
Possibility of movement or how many possible
move.
direction it can do.
Yeah, possible number movements, independent movements of a mechanical system. So it is the number of independent variables that define the possible positions or motions in a mechanical element. So can you see this joint? What is this joint? Which is this joint? What is
Knee
an?
joint.
Yeah, it is a knee joint. So you can see like all these axes, superior, inferior, then flexion, extension, then varus valgus rotation. So knee joint has all the movements possible. All the movements. You can see this is the translational, and also there is rotational along the same axis. So how many movements are possible for knee joint? Independent movements possible for a knee joint. Anyone?
Four, right?
How it is for?
Not extension, flexion, then the inversion, eversion, and that, and that's it, right?
No. See, it has movement. It can move along all the axes shown here. Like it can move. It can have this movement translation, and about this axis it can have rotation also. So how many we have seen? We have seen two. Similarly, along about this axis, it can have translational, and similarly it can have rotational. So we have two more, and similarly we have two more about this axis. So it has total six number of independent movements it can have, the knee joint can have. So it has 6 degrees of freedom. Degrees of freedom is the number of independent movements a joint can have. That is known as degrees of freedom. Now this is a hip joint. So can you say how many degrees of freedom it will have, the hip joint? Sorry, how many? Six.
Four, sir.
No, how it is four?
Abduction, adduction, extension, flexion. I think it is more than six, sir. So
No, you can refer to this figure. It is a ball and socket joint, right? And for ball and socket, how can we move this? What are the possible movements this?
here it is showing six possible movements.
Not six. How it is six?
Up, down, sideways, and rotational.
These are one, only one. Like similarly we have seen here now, if it is 6, then for this rotation, can you say this is 2? This is simply one movement, right? This movement.
Only rotation, sir.
Yeah, only rotation. Hip joint can have only rotational movements. These are shown here in this figure.
Only one movement.
No, you can see there are three rotations we can have. Three types of rotations. Like it can rotate. It can rotate like this about this axis. Similarly, it can rotate like this. So it can have three types of rotations. And because of these three rotations, we can do those. You are just saying flexion, extension, abduction, adduction. Because of these three rotations of a ball and socket joint, we can have those movements of our hip joint. So is it clear?
Yes, sir. Okay.
Okay. So there is one more, which is open and closed chain mechanisms. So first, what is a kinematic chain? It is an assembly of rigid bodies connected by joints to provide constrained motion. And when the one link of that kinematic chain is fixed with the ground, then it becomes a mechanism. So we have two types of mechanism. One is open chain and another one is closed chain. In the open chain mechanism, the terminal link in the chain is not restrained and is freely movable. And here one link is connected to a single joint. And what is a closed chain mechanism? Closed chain is terminal link meets enough resistance to restrain its free motion. So if you now see a mechanism, can you say is it a open chain or closed chain? Like seeing the picture. Is the concept clear? Open chain and closed chain?
No, sir.
Yeah, I will just show with some examples. So in this person is performing this exercise. So see, when you need to find out a mechanism, a closed chain or open chain, what you need to do, you need to draw the links. Means here we can see we can draw one link here, the hand. Then there is one joint here, elbow joint. So and you can draw another link. There is one joint, shoulder joint. This is the shoulder joint. Then here it is elbow joint, and here. So are which are the terminal links here? Sorry. Yeah. The terminal link is this link. That one holding the dumbbell. This is the terminal link. So is there any restraint on the terminal link? Like does the terminal link can rotate freely, or is it constrained? Is the movement is blocked by some other constraints? Is it a free joint or a constrained joint, the terminal link? Sorry?
Constraint.
How it is constrained?
Link, terminal link, it will not move. There is no joint, right?
Sorry, the terminal link is free to move, or it is constrained by some other force?
Terminal joint can't move itself, but it moves.
I am not saying terminal joint, the terminal link, this one. This link, terminal link. Can it move freely, or will there be some constraint? Yeah, it can move freely, like while holding the dumbbells, and you can do this motion, right? You can move freely the terminal link. So this is an
Yes.
what is the example of this? Open chain or closed chain?
Open chain.
Yeah, it is a open chain. Now coming to this, what will be? It will be a open chain or closed chain? Can you say? What you need to do? You need to draw the links here and here. So which are the terminal links here?
Between shoulder, sorry, between knee and hip,
Between knee
and
and hip?
between knee and.
No, that is not the terminal link.
So
Terminal means
terminal
what?
means
The
terminal
end,
means
the link at the end.
link at the end.
Yes.
So uh, heel and the knee behind.
Yeah. This link and this link. These are the terminal links. So these terminal links, are they free to move or there are some constraint on the ground?
So sir, the terminal, I'm not able to understand terminal link. Can you please explain once again?
Yeah, the terminal link means the link which is at the end. Like we are drawing this uh, we are drawing this person as a link, means every part of his body between two joints we are drawing that as one link. So there is hip joint here and there is knee joint here. Between hip and knee there is this link, and there is this between knee joint, and there between the ankle joint there is this link.
Yes, sir.
So the last link is known as the terminal link.
So which is the last link here?
This one I have shown with the arrows. These two links, these are terminal
So
links.
last link with body part or with.
Last link with means on which he is. It will be based on the what kind of exercise he is doing.
Because in the previous example, the terminal link was between elbow joint and the wrist joint.
Yes.
Right.
Yes.
So it was based on which means which reason, for what reason it was mean.
Yeah, because he was doing exercise using his hand, using his this part of his body. He was performing exercises using this. So that's why we have considered that as a link. And similarly in this figure he is performing one leg squat, and while doing the squat, which body parts we involve here? Only legs are getting involved, right?
Yes.
That's why we have considered this as a link, and this link is.
Okay. So between the here between knee and ankle there is terminal link, right?
Yes.
So there both their between both their elbows and wrist, that was terminal point.
Yes.
Okay, sir. Okay.
So these terminal links, there is any constraint or they can move freely?
Constraint.
Yeah, these are constrained by the ground. This acts as a fixed connection, because you can't go beyond this point, right? Beyond this point you can't go this side. So these are constrained. So this is the example of which mechanism?
Closed chain.
Yes, yes. It is a closed chain. Now you can usually say about this push-ups, doing push-ups. What is this example?
Open chain.
How it is open chain?
Why doing push-up? Because the terminal link has no constraint, right?
Oh, terminal link. Which is the terminal link here?
Terminal link is between the wrist and the
Elbow.
elbow.
Yes, yes. That is
Yeah.
the terminal link. But can you go beyond this point? Can the wrist?
But here the elbow and means the radius and ulna, the region between the elbow, wrist and the elbow will have no movement, but shoulder will have movement, right? Shoulder and chest.
Yeah. But can the
So
shoulder and
it
chest
will
go beyond this point? Then also it can't go, na?
yeah, it can't while going up or while coming down.
Coming down.
No, it can. If it goes down, then it will lie down. It can't go.
Yeah, yeah. So there is some constraint.
Yeah.
Yeah. So it is also an example of closed chain.
Okay.
And what about this exercise?
This is a open chain, right?
Yeah, because he can freely move his leg. The
Yeah.
legs can move in these directions. It is an open chain.
Okay.
Okay, now we will do some numerical problems. You can read this problem and try to understand what is asking here. Okay, I will read the problem. Consider the position of the head and neck shown in figure. Also shown are the forces acting on the head. The head weighs 50 Newton and it is acting here at the center of gravity and located at point C. And Fm is the magnitude of the resultant force exerted by the neck extensor muscles, which is applied on the skull at point A. So this is the point A, and here this force is applied by the neck extensor muscles. The atlanto-occipital joint center is located at point B. There is one joint here which is known as atlanto-occipital joint, and it is located at point B. And for this flexed position of the head, it is estimated that the line of action of the neck muscle force makes an angle theta. This angle is given 30 degree, and the line of action of the joint reaction force makes an angle beta equal to 60 degree with the horizontal. So this is 60 and this is 30. What tension must the neck extensor muscles exert to support the head? What is it asking? It is asking this force Fm. And what is the compressive force applied on the first cervical vertebrae at the atlanto-occipital joint? And it is asking this force Fj. Is the problem clear to everyone? Have you understood the problem?
Sir, no, sir.
Which part you didn't understand?
Certain force extension message. Sir, what do you mean by magnitude? F1.
This magnitude. Which magnitude?
F1 is the magnitude of the potential. That magnitude means what?
Magnitude means the amount of force. Like force is a vector quantity, right? Yeah, and the vector has magnitude and direction both. So
Okay.
direction is given by this, and magnitude means the value of the force.
Okay.
Is it clear?
So, sir, line of action.
Line of action means this line. This line.
Which one, sir?
See, there are two line of actions here. One is for FM and one is for FJ.
Okay.
Line of action means the direction of that force along which it is acting. It is acting along this direction, right? From A, FM.
Okay, sir. From B, it will be.
On B, and there is a compressive force FJ, which is the joint reaction force.
Okay.
And it will act along this direction.
So force is acting downward or upward? Downward, right?
Yeah, FM is acting downward, but FJ is acting upward. Not upward. It is acting at an angle. There is an angle here, beta.
At angle beta.
Yes, yes. If it is 90 degree, then we can say it is acting upward. But here it is making an angle of 60 degree. So it is a not upward force.
Okay, sir.
Yeah, I think you have not gone through my previous lecture, tutorial lecture. You can go through that lecture. In that video, I have explained everything about this force, magnitude, directions, line of action, all these things.
Sir, in that video, clarity is not there. Sir, in that video, clarity is not there. Visibility is very poor.
Oh, is it? Means my slides were not visible?
Slides were not visible because the screen is very short, and other parts of the screen were visible.
Okay, yeah, yeah.
Advertisement comments was open. The screen size is very short. When we expand the size to review the slide, it is means not giving proper visibility.
So where is the video available, sir?
Yeah, already it is available.
Where is that available?
It is available.
Last week.
Yeah,
last week video.
On the NPTEL web page, if you can see on the left side, problem solving sessions.
Okay. Because I missed the live session, that's why I gone through the recorded session, but the screen size is very small. When I expand the zoom the screen size, the visibility is not clear too because font is very small.
Okay, I am sorry about that, but what I can recommend, you can use your laptops or computers to watch that.
No, the screen size is same. Even the tablet and laptop I tried on free gadgets.
Okay, okay, okay. Okay, if you don't understand anything, then you can ask me in this video. I will explain it again. So now is my screen is visible properly to you? What I am sharing and explaining?
Yeah, today in live situation it is visible and expandable, so that's no problem. But that last video sticks, if I expand it or zoom it, the pixels lost the quality of the visuality.
Yeah, okay, I can understand that. Yeah. So now we will solve this problem. If you don't understand anything, you can ask me at any point. So there are two methods to, I will show two methods to solve this problem. Like method one is I will take the components of force.
So the question, did you provide the diagram?
Yeah, this is the question.
Diagram will be present there as well in the question.
Diagram it is here, no? It is showing here.
Okay.
Now I will consider these forces in my next slide. So consider, see, all these forces are passing to this point, right? O. All these forces are passing to point O. You can understand this, na? And these forces W, then Fz, then Fm. All these forces are passing to point O. So we will take point O as our reference point. This is point O, and here we have seen the W force is acting vertically downward, and there are Fj which is acting at angle 60 and Fm at angle 30. See. So is this diagram clear? We have considered this as point O, and this force W is acting vertically downward. Fj is acting at an angle 60 with the horizontal, and Fm is acting at an angle 30 with the horizontal. Is this clear? Have you understood this?
No, sir.
Which part you didn't understand?
Fm was upward, right?
Sorry, which? Fm?
In the previous diagram, in the skull diagram,
Fm was downward.
so Fm is downward.
Yes, and Fj is upward. Not upward, at an angle 60 and at an angle 30.
As an angle 30, but the arrow pointing is downward in Fm.
Yeah, yes.
So the force is acting backward.
I have also shown that. See here Fm is acting this direction na, downward.
Oh, downward direction. Okay.
Yeah, and weight W is given as 50 Newton.
W. Okay. So one force we know.
Yes, we have two unknowns here, Fj and Fm.
Okay.
So to solve this problem, like in my previous video, I have told that to solve a mechanics problem, there are some equilibrium conditions which we need to consider. Like we consider this as a problem of equilibrium, and the conditions for equilibrium are summation fx equal to 0 and summation fy equal to 0. Means there should not be any force which is acting in any direction x and y. If there is any resultant force which is acting on a system, that system is not considered as equilibrium. And in solving all the biomechanics problems, we consider the system as in equilibrium. So we consider that there is no net force acting on the system. The net force acting on the system, we take that as 0. That's why we have written these two equations, summation fx 0 and summation fy 0. Now summation fx 0 will take the components of these forces. What is the component of this force Fm along the x direction? What will be this component along this direction x?
Fx cos 30.
Yes, yes. It will be Fm cos 30. And what will be the component of this W along the horizontal, along the x direction?
Fx Fw cos 90.
Yeah, but cos 90 comes as 0, so it will come as 0. We will not consider there will be no horizontal component of W because of W. And because of Fj, we have Fj cos 60, but it is acting in this direction, in the negative x direction, so we will take it as minus Fj cos 60 equal to 0. So this is one equation we have found, equation 1. And similarly, we will find the equation along the y direction. For the y component, the component of Fm will be Fm component of Fm along this direction will be Fm sine 30, but that is acting along the negative y axis, so it will be minus Fm sine 30, and the component of Fj along this direction will be plus Fj sine 60. These two equations you can understand, right? Anyone has doubt in these two equations? Oh, sorry, there will be minus W also here because I forgot to consider this W. Along the y direction there is W. So are these two equations clear? Have you all followed?
Sir,
Yes.
why a summation of fx is 0?
This is the condition of equilibrium.
Okay, in condition of equilibrium, summation of fx and summation of fy will be 0.
Yes, yes, you are correct.
And cos 30, reason of taking cos 30 is?
The component of this force Fm along the x, we are considering along the x direction, right? Summation of fx means all the forces acting along the x direction. So we need to consider this component of all these forces acting along the x direction.
Okay.
Yeah. So now we need to solve these two equations to get the answers. Like from equation 1, we can write Fm is Fj cos 60 divided by cos 30. Now we can substitute this Fm in equation 2. That will be minus Fj cos 60 by cos 30 sin 30 plus Fj sin 60 minus W is 50 equal to 0. Now we have this equation, and what is the unknown in this equation? Only unknown is Fj. So we can find out what is Fj. What will be Fj? Fj will be, we will take 50 on the right hand side. 50 divided by sin 60 minus sin by cos, we can write as 10 30 and cos 60. So if you calculate this will give us Fj. Can you find out this answer if you have calculator with you? Has anyone calculated? Anyone found out this? What will be this? Okay, it will be 86.6 Newton. So we have found out Fj. Now using this equation, Fm equal to Fj cos 60 by cos 30, we can find out Fm. Fm will be 86.6 cos 60 divided by cos 30. What will be this answer? What is Fm? Are you guys doing the calculations? Fm will come as 50 Newton, equal to the weight of the head, weight of the skull. So is it clear? Have you all understood this problem? Is there any doubt? Can I proceed? Okay. So I will show now next method, how we can solve the same problem using another method. That method is known as vector force method or force vector method. In this method, we will use the vector. We will consider force as a vector and we will draw the vector triangle of force, because there are three forces which are in the system. So using the three forces, we can draw a triangle and we'll use that triangle to solve the unknowns which are asking Fm and Fj. So the three forces are W in the vertically downward direction, then Fm also in downward at an angle of 30, and Fj is upward at an angle of 60. How we can draw all these three forces? We can draw Fm here, sorry, W here, then Fm here, then Fj here. W, Fm, Fj. So is this diagram clear? W is acting vertically downward, then Fm is acting at an angle 30 degree, and Fj is acting at an angle of 60 degree. So is this diagram clear? The vector triangle.
Yes, sir.
Okay. So what will be this angle?
And 30.
Yeah, it will be 30. It will be 30, and this angle we don't know. Hmm. Or we can apply some geometry to find out this angle. This angle. See, in this figure, this angle is 60, and what will be this angle? This angle will also be 60, right?
Yes, sir.
Yeah, this angle will be 60, so this angle will be 30. So we can find out this angle because the summation of angles in a triangle is 180. So two angles are 30 and 30. 30 plus 30 is 60, so this will be 120. This angle is 120. Now in a triangle there is one sine law which we can write. That law says that this force Fm will be proportional to the angle between the other two forces. That means Fm will be proportional to sine of this angle 30. Fm by sine 30, and it will be equal to Fj by sine 120 equal to W by sine 30. See, this is W, right? Uh, this vertically downward component is W. And what is the opposite angle? Opposite angle to the W? This is 30. So we have considered W by sine 30. This 30 is the angle between the other two forces. If we consider W, then the other two forces are Fj and Fm. And angle between the Fj and Fm is this angle, 30 degree. That's why we have taken 30 here. Similarly, for this force Fj, which is the Fj force here, this side of the triangle. This side is Fj. And what is the angle between the other two forces? W and Fm. This is Fm. So angle between W and Fm is this angle, 120. That's why we have taken sine 120. And similarly, we have taken Fm by sine 30 because Fm is this side and angle between the other two forces Fj and W is 30. So we have taken sine 30. So is it clear? Have you all understood? This law is coming from trigonometry. So have you all followed this method?
Yes, sir.
Okay, so now using this equation, we can directly find out what are Fm and Fj. Like Fm will be just W, because sin 30 and sin 30 will get cancelled out, and Fj will be W into sin 120 divided by sin 30. So if you do this calculation, it will again come as 86.6. This will be 50 Newton. So in our previous method 1, we solved using the force components, and we have seen same answers we are getting if we use another method. So I think it is clear to you. So now I will move forward. Yeah, this is the second problem. Okay, I will read the problem. To compare Homo sapiens and Australopithecus hip joint mechanics using similar skeletal materials. What is an Australopithecus? If Australopithecus is our ancestor, which is shown in this figure. This. Now researchers studied the skeletons of Native Americans male recovered in the field rather than those from laboratory cadavers representing modern Americans. They estimated interfemoral head distance and abductor momentum distance from the archaeological remains of 8 Homo sapiens and 1 Australopithecus. These results are shown in the following table. Assume that the body weight momentum is equal to half the interfemoral head distance shown in the second column of the table. Assume also that the abductor momentum C and angular S shown in the third and fourth columns. What can you deduce about the hip forces in Native American compared to the hip forces in the Australopithecus individual? So have you understood the problem? See, these informations are not important to us, what they did to find out the data, to means they estimated how they did the estimations. All those things are not important to us. Only important is what are the given data that will be required to solve our problem, and those informations are given here. The body weight momentum is equal to half the interfemoral head distance DIF. Where is DIF? DIF is here, given here in this table. And abductor momentum C, and angle abductor momentum is here C, and abductor angle is 15 degree. Now you need to find out the hip joint reaction force. See, this is the diagram for hip force. Here P is the abductor muscle force and C is its momentum with respect to the joint center. B is the momentum of the body weight minus the support leg 5W by 6. So this force P is abductor muscle force. And for this muscle force, the C is given here. C is 36 and 50.6 for Homo sapiens. And abductor angle is angle between this abductor muscle force and the vertical y-axis. This angle is given 15 degree. And hip joint reaction force will act along this direction. What is B? B is given as B equal to 0.5 DIF. Because here it is mentioned equal to half the interfemoral head distance. So is it clear? Okay, now I will solve this problem. Here, what we need to find out? We need to find out Fj. And to find out Fj, the given data are B is known to us, then 5W by 6 it is given, C is also given, but P is not given to us. So first we need to find out P. How we can find out P? For Australopithecus hip joint. For this hip joint, DIF is 132 mm. Then abductor momentum C is 36. And abductor angle is 15 degree. Now we can find out B. What is B? B is 0.5 into DIF. That will be 66. Yeah, 66 mm. Multiplied by 0.5 multiplied by this 132. So we have found out what is B. Now we need to find out the P. How we can find out P? We are considering this point as O, the point at which the joint reaction force is acting. So if we consider that point as O, we have to take the moment equilibrium about that point. Moment equilibrium about point O, that should be become 0, and this is also a one condition for equilibrium. So if we do this moment equilibrium about O is 0, then we will get see 5W by 6, it is acting in the clockwise direction, so it will give us a clockwise moment, and P is acting in the anti-clockwise direction about this point O, and it will give us an anti-clockwise moment. So we are taking clockwise moment as positive, so it will be 5W by 6 multiplied by, what is the moment term? Moment term is B minus P dot C equal to 0. About the point O, there will be no moment due to this force Fj. So now we can solve this equation. If we solve this, we will get Pc equal to 5Wb by 6. From here, what will be the value of P? P will be 5Wb by 6C, and we can put the values 5W dot 66 divided by 6 multiplied by 36. What will be its value? 5 into 66. This value will be 1.53 W. So we have found out the value of P, 1.53 W. Now you can use that force vector method to solve this problem. Like we can construct a triangle using these force vectors which are given to us. What are the forces? Those are given to us. Like one force is in the vertically downward direction, 5W by 6. Then the joint reaction force is acting along this direction, and force P is acting along this direction. What are these forces? These forces, 5W by 6, this is Fj, and this is force P. And this angle is given, this angle is 15 degree. So if it is 15 degree, this angle will be 180 minus 15, which will be 165 degree. So we can find out the magnitude of this Fj. Like from the trigonometry, if this is a force triangle, then the resultant force Fj, there is a formula from the trigonometry that is given by P square plus 5W by 6 square minus 2P into 5 by 6 cos 165. This formula comes from the vector mathematics. like if there is a force triangle and two forces are known to us, then we can find out the resultant because of those two forces using this formula. So now we can substitute the value of P. The value of P is 1.53 square W square plus 5 by 6. This will come as 0.69 W square minus into, and this will be plus 1.6 W square. Sorry, it will be, we need to substitute the P. Plus 2.46 W square. So now we need to solve this to find out the value of Fj, which will be 2.34 W. So the joint reaction force for this Australopithecus hip joint will be 2.34 times weight, 2.34 times body weight. Now we can solve this problem for this case, Homo sapiens Native American male. For that, what are the given values? For Homo sapiens, DIF is 158. We are taking this mean value 158, then 50.6, then 12.9. 158, 50.6.
Sir,
Yes.
sir, for the first one,
Yeah.
for
Wait.
Australopith.
Yeah.
Australopith.
Yeah. Australopithecus. Yeah. Yeah. Yes.
Yeah, Australopith.
Yeah. Forget about the name. Yeah. Tell me what is your doubt.
So you had find Fj, right?
Yeah. FJ. Yes.
Yes. So P you had find by 0.5 into DIF as mentioned in the question, degree of freedom.
Yeah.
Sorry, degree of
Yeah.
degree of freedom.
It is not a. It is not a degree of freedom. DIF is Just a notation they are using DIF.
Yeah, so DIF was one of the variable which mentioned in the question that it was half of the
Half
D,
of
right?
DIF, yes.
D is equals to half of DIF.
Yes.
So how it got 66 meters as DIF was 132 meters. Okay,
Yeah.
it was 36 mm and it
Sorry.
was given in the question. Yeah.
Is it correct?
So,
132. Yeah, it
so
is 66.
FW, why FW by B?
Sorry, which one?
The first step, summation of M0 is equals to 0.
Hmm.
Then it's mentioned FW by 6 into P.
Yeah, that diagram I didn't draw. Like there is point O and there is one force which is acting 5W by 6B here, and there is one force which is acting here P, and this distance is C. I am taking a moment about point O. And what is a moment? Moment is force multiplied by the moment arm, or we can say it lever arm.
Moment is force into
R.
R is
R is the distance from this point at what
FD.
at what distance the force is acting. Yes.
What distance force is acting?
Yeah. This is known as moment arm.
Okay. Momentum.
Yeah.
And PC.
Yeah. P similarly P is the force and C is the moment arm. That's why I have taken PC.
C is the force. Okay. P is the force.
Yes.
Same distance.
Yeah.
So PC is force into distance, right?
Yes. Because here P was unknown to us. These values were given in the questions.
Okay. So PC is given, then B 66 and C 6 into C is 36. Okay, 1.53.
Yes.
So Fj is which this is vector formula.
Yeah, this is the vector formula.
Fj is equals to resultant force is equals to the two opposite forces. Means two forces, right? Under root of okay.
Yeah, is it understood?
So, then we have find the force, right? 2.34 is the work done or it is the force, right?
It is force, yes. Means I have calculated
So we
this.
have to find the
Yeah, W is the weight of the person. It is not given.
okay, weight.
Yeah, yes.
Okay, so 2.34 into weight.
Yes.
Okay, sir.
Okay.
Continuous.
Okay. So now
I
I will.
hope. Yeah.
Sorry.
Only two of us are there, I hope.
Yes. Everyone left. Just I will solve this problem, then I will close.
No problem, sir.
Yeah.
Continue.
Okay. Yeah. And see, for Homo sapiens, this data I am taking the mean data. Here they are given some extra plus minus data, which were the deviations from the mean. I am considering only the mean data which is given. Like DIF is 158. MMC is 50.6. And theta is 12.9. So I will follow the same method as we followed for Australopithecus. B, first we will find out the B. B is 0.5 into DIF, and this will come as 79 mm. Again, I will do that moment equilibrium about 0.0. This is 5W by 6 at the distance P, and this is force P at the distance C. So moment equilibrium about 0, which will give us 5W by 6. It is creating a clockwise moment, so I will take clockwise as positive. 5W by 6 multiplied by B minus P is causing a anti-clockwise moment about 0.2, so P dot C equal to 0. From this equation, P will be 5W B by 6C. Now here B is 79, so we can substitute those values. 5 into 6 into 50.6. It is 1.3 W. Again, we can use this formula, Fj, like the same formula we have used in previously. Oh yeah, only thing that is getting changed is P, the value of P. Fj will be square root of P square plus minus 2 cos 165. So it will come as, we can substitute 1.3 square plus minus. Now we can solve this. Square plus 5 by 6 minus. If you solve this, you will get 2.1 W Fj. If we solve this problem. So previously what we were getting? We were getting 2.34. Now we are getting 2.1. So if the W is same, like the weight of this Homo sapiens Native American and this Australopithecus is same, then we can see that for Australopithecus the hip joint reaction force is little bit higher than the Native American Homo sapiens, which is 2.1. So is it clear?
Okay, sir.
Yeah, yes.
Yes, sir. Sir, I just had a doubt.
Yes, yes.
So, in this step,
Hmm.
so why we consider considered 5 by 6 into W?
That is, I think they have mentioned here. Here, body weight minus the support leg. You can see. Sorry, yeah, minus the support leg. So they have subtracted the weight of this leg which is supported. Like if the person is supporting on this leg, they have subtracted the weight of this leg, W. Is it clear?
What, sir? No, sir.
See, means while you are walking, then when your one leg comes in contact with the ground,
Yes, sir.
then means that position they are considering. Like at that position, what is the hip joint reaction force? Because when your one leg is in contact with the ground, what will be the other body weight? If your total body weight is W,
Yes, sir.
so the whole body weight will not act. Means this leg, the weight of this leg will get subtracted.
Okay.
Yeah, that's why they have considered it as 5W by 6.
Okay, 5W of 6. Okay. The moment arm of the body weight minus the support leg. Okay.
Yes.
Okay, sir.
Okay, so is it clear? Okay, so do you have any more doubt?
For now, no, sir. I have to go back to my physics course. I have to revise all the things and I have to do this
Yes.
calculations.
Yeah. Or you can watch my previous tutorial video, week 1.
Yes, sir. Previous week video I watched.
Okay. Yeah, okay,
Okay,
thank
sir.
you. Thank you for joining. And now you can leave.
Thank you. Thank you for teaching, sir. It's my pleasure.
Yeah, it's okay. No problem.
Okay, sir. Thank you very much.
Yeah, thank you. Okay.